Hello student. In this lecture I am going to cover the epicyclic gear train. In previous lectures we have covered simple gear train, compound gear train and reverse types gear train. Now before going to proceed epicyclic gear train, I I want to mention some uh, specific thing between previous gear trains that in simple, compound, and reverse gear train. In these gear trains, uh, one shaft of a gear and other shaft of the gear is always there is fixed. There is no motion between these two shafts. Yeah, between these shafts. So this is the important point that you should note that uh, in simple gear train, and as we have seen that gears are attached with their own shaft and shaft is not rotating about each other. And similarly in compound gear train, gears are attached on the same shaft, but the shafts are not rotating about. Or we can say there will be no relative motion between any two shafts. Similarly, that was the case in the reverted gear train. Now we come to the epicyclic gear train that we are going to start. So in epicyclic gear train, this is the case in which one shaft can rotate about the another shaft. Yeah, in other words, we can say one shaft can move uh, around the another shaft. So, this type of gear trains are called epicyclic gear trains. Here in this figure, you can see that there is a gear A and there is gear B with that is in mesh, and there is a arm C. So, gear A is rotating about its axis O1, and gear B is rotating about the axis O2, and the arm C is fixed now. So if the arm C is fixed, then gear A and gear B will just like a simple gear train, uh, because they will move about their axis at their own position. But if the arm is not fixed, if the arm is not fixed, and we fix only the gear A, then gear B can rotate about the gear A. So this type of case will be called epicyclic gear train. So, in other words, I can say if the arm is fixed, the gear train is simple and gear A can drive gear B or vice versa. But if gear A is fixed and the arm is rotated about the axis of gear A, then the gear B is forced to rotate upon and around gear A. As such motion is called epicyclic, and the gear trains arranged in such a manner that one or more of their members move upon and around another member is known as epicyclic gear trains. So the epicyclic gear trains may be simple or compound. Uh, now there are some points that should be noticeable here. The epicyclic gear trains are useful for transmitting high velocity ratios with gears of moderate size in a comparatively lesser space. The epicyclic gear trains are used in the back gear of lathe, differential gear of automobiles, hoist, pulley, blocks, wristwatches, etc. So uh, now we see how can we find out the velocity ratios in the epicyclic gear train. And this there is a very important method called tabular method that I'm going to discuss with it. So in tabular method, as you can see here, we make a table. Here we make a table. The table is given here. A table is uh, as you can see here. It has been drawn. In this table, there are first column is step number, second column is conditions of motion, and another column is the revolutions of elements. Okay, so if uh, if we see the uh, this case, that is figure 13.6, according to this, if I draw the table, how can I draw? I am going to discuss that. In this, what we have to do first, if any type of epicyclic gear train that you have given, first the first word that you have to do is that first action will be you have to fix the arm. So first action is arm is fixed. When you will fix the arm, then gear A and gear B, here it will rotate like a simple gear train. They will rotate like a simple gear train. So when the arm is fixed, so there will be no more when the arm is fixed and gear A and gear B are at rest. Now, if I give the plus one rotation to any convenient gear, here I can take A or I can take B. It depends on the uh, user, or it depends on the particular person who what does he considers convenient. But here I am taking as a gear A as a convenient, and I am going giving you I am giving is the plus one rotation. Here the plus and minus means I am taking the positive sign for the anti-clockwise rotation and the minus sign for the clockwise rotation. It you can take accordingly, that if you select plus is a clockwise, minus anti-clockwise, you can take it accordingly. It doesn't matter, but uh, it's just like a convention. It depends on the person to person what does he take. So here plus has been taken for the anti-clockwise and minus taken for the clockwise. So I am giving the plus one rotation to the gear A. That is, I am rotating gear A in anti-clockwise direction. If I rotating the gear A in anti-clockwise direction in plus one, then what will be the rotation of B? That can find out by the velocity ratio expression, that is NB by NA equal to TA by TB. So from here you can, in the step number, you can see that uh, uh, arm is fixed and gear A rotates through plus one rotation. So the rotation of gear B is given minus TA by TB. Now, if the gear A is rotated by plus x revolution, or we give the plus x revolution to the gear A, then it will be multiplied by plus x to the column. So in the second column you can say gear A will be plus x, and the gear B will be minus x TA by TB. Now, if now if I also rotate the, yeah, or we can say if I also give rotation to the arm. Let's suppose I give rotation to the arm plus y. Plus means if I give rotation plus y means I give rotation uh, y rotation anti-clockwise direction to the arm. Then what will be the value of rotation of A and B? So here you can see that if you give plus y rotation revolution to the arm, then it will uh, then arm rotate will plus y, gear A will be plus y, sorry, plus x plus y, and gear B will rotate with minus x TA by TB and plus y. So this completes the table. And now after that, according to question, it can be uh, uh, the question can be solved according to the conditions. So for today, uh, let's suppose there is an example for this epicyclic gear train is given. I am going to discuss this example. In this example, let's first of all I read the question. In an epicyclic gear train, an arm carries two gears A and B having 36 and 45 teeth respectively. If the arm rotates at 150 rpm in the anti-clockwise direction about the center of the gear A, which is fixed, determine the speed of gear B if the gear A, instead of being fixed, makes 300 rpm in the clockwise direction. What will be the speed of gear B? So gear train is so here in the diagram it has shown you the gear A and gear B are messing with each other, and there is a arm C. Now gear A has given 36 teeth and gear B has 45 teeth. And the arm is rotating with a 150 rpm in the anti-clockwise direction. So we have to find out uh, the speed of gear B if the gear A, instead of being fixed, makes 300 rpm in the clockwise direction. Okay, let's see in this table. This is the table that we have obtained from the previous question. It's the same table and the same question. The diagram of the question is same as the previous before. So we will make the table accordingly that we have made before. So now we put the condition in this table. So we have to find out when the what will the speed of gear be when gear A is fixed. First condition is that. So what is the speed of gear A? We can read the row 4. In row 4, speed of gear A is x plus y. So we are going to do plus x plus y equal to 0, that we have put here, and we will give the value of y, and y is what? Y is 150 rpm, that is anti-clockwise, so this will be as taken as plus, so y will be minus 150 rpm. So now the value of y, when value of y have been find out, now we can find out the speed of b. So from the table, speed of b is y minus x ta by tb, so this can be written as y minus x ta by tb. So from here you can see that the speed of gear b is 270 rpm. Now the second part is that speed of gear B when gear A makes 300 rpm clockwise. So again from the table, from the row 4, now plus x plus y equal to minus 300, because here 300 rpm in clockwise, so this will be taken as minus. So x plus y equal to minus 300, so from here y value will minus 450 rpm. Now speed of gear B again from the table, that is y minus x ta by tb, so put it the value of y and x, you get the answer 510 rpm. So this is the way to do the question of epicyclic gear train. In the next lecture, we will discuss some more problems on the epicyclic gear train. Now today I am going to end the lecture here. Okay class, thank you.